Hello, second grade scientists and second grade engineers. Today, you will be both as we explore the property of strength. Think, what does the word strength mean to you? Think about its meaning, and I want you to whisper it into your hands right now. Ready, set, go. Okay, 1, 2, 3, eyes on me. So maybe you're thinking that the word strength means someone or something that's really strong. Like, for instance, a bodybuilder has really strong muscles. They have a lot of strength. Well, you're right. But bodybuilders aren't the only ones with strength. Objects and materials can also have strength. Let's think of some objects that are strong. Can you name some objects that are strong across your fingers? I'm going to just show you one and then see if you can name some others. Ooh, a bridge. A bridge is really strong, right? It can hold up lots of cars and it can stretch all the way across a large body of water without falling. Bridge is certainly strong. See if you could come up with some others. Ready, set, go. All right, eyes on me, everyone. So let's see, I came up with some others. Let's see if you had any of the same ideas as me. Buildings. Buildings are certainly very strong. Look at this building here. This is called the Freedom Tower. It's located in New York City. And look at just how tall this Freedom Tower is. It must be really strong to be able to stand up so tall without falling over. This is another object that's strong. Now, this object, a hammer, it's not big by any means like a bridge is or like a building is, but it's still very strong. And how do we know that it's strong? Well, when we use a hammer, we use it with a lot of force, right? We use it to bang nails, make repairs, and even though we're banging it really hard, it doesn't break, so it must be very, very strong. Now let's think of some materials that are strong. Think about the types of materials that are used to make things like bridges and buildings and hammers. I'll name one material and then I want you to see if you could come up with some more. Metal, right? Metal is a very strong material. Steel, in fact, is a type of metal that's known to be very, very strong. Can you come up with some others? Name them across your fingers. Ready, set, go. All right, 1, 2, 3, eyes on me. Let's see if you came up with any of the ideas that I came up with. So we already said metal. Wood. Wood is very strong. Your house is likely made of wood. And think about how strong your house is. You couldn't just push your house over, right? Stone. Stone is certainly very strong. Lots of structures are made of stone. Some houses are made of stone. Walls are made of stone. Brick, again, very, very strong. And again, your house or a building might be made of brick. I have a book here that I'd like to read. It's called So Strong. And I'd like to read this as a shared reading. So would you please read out loud with me? All right, try to read in your smoothest reading voice. This book is called So Strong and it's written by Pam Holden. A crane is very strong. It can lift heavy things like a car. An elephant elephant is very strong. It can carry heavy things like logs. Nice smooth reading voice. Let's keep going. A rope is very strong. It can tie up a big ship like this one. A digger is very strong. It can dig big holes like this. A horse is very strong. It can pull a heavy cart like this one. The wind is very strong. It can blow big things over like this tree. An engine is very strong. It can pull a heavy train like this one. The sea is very strong. It has big waves like this. Thank you for reading that book with me. Right now, as quick as you can, name 3 more things that you can think of that are very strong. Ready, set, go. All right, great job, everyone. Now let's hear what my friend Dr. Jeff has to say about the property of strength. Now let's hear what my friend Dr. Jeff has to say about the property of strength.
I'm Dr. Jeff, and today we're learning how materials have properties that make them good for certain purposes, like a pizza chair. Wow! Not bad. Welcome to 3, 2, 1 there. It's a pizza chair. Today, we'll discover that some materials have properties best suited for certain purposes, like strength.
3, 2, wonder! Yeah! 3, 2, wonder! Hey! Let's go! 3, 2, wonder!
Hey, Addison. What's going on?
Hi, EJ. I'm trying to open this toy, but the package is impossible to open.
Just do what I do when I can't open anything. Throw it as hard as you can. Feels good, doesn't it?
Well, that's one material that's definitely serving its purpose.
The purpose of making me mad.
Or using its strength to protect the toy that's inside. Different materials have different qualities, and scientists call them properties.
Things like flexibility, color, or in this case, strength.
That's right. And those properties help serve a purpose. In this case, it's to protect the toy.
So the property of a sign is that it is brightly colored. And the purpose of it is to be seen easily.
That's right.
Or one property of a brush is that it has a rough texture. And the purpose of that is to scrub things to clean them.
Exactly. Today, we're going to test the properties of different materials and learn about their purpose, starting with strength. I think I pulled a muscle. Time to go into our imagination. Follow me. Here we go. In 3, 2,
wonder!
Our imaginations are so colorful.
They are. Today, we're going to test 3 different chairs. One made of metal, another one made of cardboard, and the third one is made out of a mystery material. We can test these chairs by having Addison sit down in each chair to see which chair is the strongest. Let's start with the metal chair.
The metal chair holds up my body and isn't moving at all.
Excellent. Now let's try the cardboard chair.
I can sit in the cardboard chair, but it feels very wobbly and it can break at any minute.
Good observation. Now let's test the last chair. The mystery chair is made out of cake!
At least it has frosting.
So, what did we learn from this?
I think the metal chair was the strongest because it held her weight and didn't break.
And the cardboard chair was less strong because while it holds me up, it was bending at the ends.
Which means the cake chair was the least strong because it completely fell apart.
That's right. If you want to build something strong, you should probably make it out of metal, not cake.
So that's why bridges and buildings are made out of metal or concrete.
The stronger the material is, the less likely it is to break.
Excellent. Now,
Thanks for that, Dr. Jeff. He's pretty silly, isn't he? So, Dr. Jeff was talking about how different materials have different levels of strength. For instance, metal is very strong. Cardboard is not quite as strong, and cake, as we saw, is not very strong at all. Well, you know, engineers, they don't only think about the materials that they use, but they also think about the way in which they use them. When engineers design structures or buildings or towers or bridges or homes, whatever it is that they're designing, they make sure to build them in a certain way so that they will be as strong as possible. Well, I had told you that today we'll not only be scientists, but we'll also be engineers. So right now, I need you to put on your engineering cap. That's right, put on your engineer's hat because it's time for an engineering challenge. We are going to build a tower by using the following materials. You'll have 10 index cards and unlimited tape. So if you're at home, make sure that you have these materials in front of you. You can pause the video here if you don't have them, and then come back once you have them. If you're in school, your teacher will give them to you. You should have your own Scotch tape or some kind of adhesive tape in your supply bin. So you'll want to make sure to take that out, and your teacher will give you 10 index cards. Pause the video here and unpause it once you're ready to learn about this special challenge. All right, so here's our challenge, engineers. You're going to build a tower out of 10 index cards and tape. And as I said before, you can use as much tape as you would like. Your challenge is to make the tower as tall and as strong as possible. You will test its strength by stacking either pennies or tiles on top. So if you're at home, you probably don't have these tiles, but you can use pennies. They work just as well. In fact, that's what I'll be using. Okay, you could use pennies. If you don't have a lot of pennies, you could use dimes, you could use nickels. Whatever it is, though, I would use all of the same. So either use all pennies, all nickels, all dimes. You get my gist. If you're in school, your teacher will give you colored tiles or something similar that, again, is all the same. So you're going to build your tower, and then you'll see how many pennies or how many tiles you can stack on top. Just to give you an idea of what I mean, I'm going to show you two towers that I've created. So I've created this one first. Look at how tall it is. It's so tall it doesn't even fit in the camera. Really, really tall. I haven't tested it yet. I'll test it in a little while with you. And then I'll show you the other tower that I made. This was the second one that I made. Okay. Now, if you're learning from home, like I did, you can make 2 different towers to see if you're able to build a stronger tower the second time. Maybe you'll learn from what you did the first time and be able to build a stronger tower. In that case, you'll just need 10 more index cards. Now, if you're learning in school, after you've built your tower, you can look at the tower of someone sitting next to you to compare your tower with that person's tower and how many tiles your tower was able to hold versus their tower. Once you're finished building your tower, I want you to come back to this video because we'll talk about our activity sheet and how we're going to record what we've learned. You see, one thing that engineers do is they teach others. So we're going to talk about how we can teach others what we've learned from our engineering challenge. I'll see you soon. Have fun building your towers, everyone. Welcome back, everyone. So I want to mention one thing. If you don't have the materials to do this challenge on your own right now, that's okay because you can learn from my experience and you can use my towers to help you write up your activity sheet. Maybe you'll be able to do this challenge at a later point. But now I'm ready to test out my towers. Okay, so for you, if you're building 2 towers at home, you'll want to test out the first one and then build the second one. But just to save time, I'm going to test out my first one and then test out my second one right in front of you. I've built them both. Okay, I've already tested them on my own, but now I'm going to test them in front of you. So with this one I really was trying to make it as tall as possible. You can see with me sitting down, it's even taller than me. It's like pretty huge. So now I have to see if it's strong enough to hold up pennies. So I'm going to start with just 1 penny. It can't even hold 1 penny. In fact, I don't even think it holds itself up. If I let it go, it does hold itself up. But once I put just even 1 penny on, it falls over. Okay, now let's take a look at my second tower. So I learned from the experience of my first tower. And when I built my second tower, I thought about how I could structure it so it would be stronger. And I thought, well, with this tower, let's see, I used like a cylinder here. I made my index cards into a cylinder. And I only used 1 of each for each level, 1 cylinder. And it didn't hold very well. And then also like I really was like, oh, I'm really going to go for the height. And then I did like a double cylinder here. Do you see how I did that? And I think that in doing that, I lost a lot of strength. So for this one, what I tried to do was number 1, I used a different shape for the columns. Instead of using a cylinder, like I did with this one, I used a triangular prism, which is just a fancy name for like a 3D triangle shape. I'll show you. I'll take this off for just a second so you can see, like, this is what I decided to do. And as you could see, I also decided to use 2 of them for each level. I thought that that would give better support and make my structure stronger. So now, although it's not as tall, let me see if it's strong. Let me see how strong it is. I'm going to pile up my pennies. You can count them with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my goodness, I need to even get more pennies. Hold on one second. Okay, keep counting with me. 11, 12, 13. Wow. So it was able to hold up 13 pennies before it fell over. Oh no, it fell over on the 13th. It was able to hold 12 pennies before it fell over. That was a pretty strong tower, right? Definitely not nearly as tall as my first tower, but my first tower wasn't even able to hold up itself. So now I want to think about what I could teach others, what lesson I could teach others about building a tower that is both strong and tall. Let's take a look here at our activity sheet. The directions say build a tower out of 10 index cards and as much tape as you would like. Build the tower as tall and as strong as possible. Test the strength of your tower by stacking pennies or math tiles on top of your tower. And then it says draw a replica of your tower. It should say tower or towers because you might be making 2 towers. Draw a replica of your tower here. So I'll fix this in the copy that you get. It should say tower or towers. Now a replica just means like a copy of, like it's like a drawing of it. So I've done that. I drew a replica of, this was my first tower, which was much taller than my second tower. This is my second tower. And you can see how I used a different base, right? Now go ahead and draw your replica, and then you can come back here to talk about what we'll do next. We're going to turn the sheet over and do the back of the page next. I'll see you in a few minutes. Pause here, come back when you're done. Welcome back. So now on the back of our activity sheet, the first question we have to answer is how many pennies or tiles was your tower able to hold? So I've answered this question in 2 complete sentences. I wrote, my first tower held 0 pennies, right? Because it didn't hold any at all. My second tower held 12 pennies. Go ahead and answer that question. And then you're going to go on to this question. It says, what tips do you have for other engineers in building a tower that is both strong and tall? Let me think, what tips do I have for others? Well, think through this. Since my first tower did not hold any, I want to really think about what I did differently for my second tower. So for my second tower, I used triangular prisms, or you could just say, I could just say 3D triangles, to hold up my tower. And for each level, I had 2 columns or 2 triangular prisms. That made my tower strong. Okay, so I'll go ahead and I'll write that. I want you to think about what tips you could give a fellow engineer, because engineers and scientists learn from each other. So you want to help out your fellow engineers and give them some tips, something that they could learn from the experiment that you did, the tower that you built. All right, thank you so much for learning with me today and for building with me today. I hope you had fun with this lesson. I know I did, and I will see you next time. Bye-bye, second grade engineers.